For today's activity, we are going to be drawing shapes using loops and variables and functions. So we're not going to be just driving them using the movement blocks like we've done the last few days. We're actually going to do those within a loop block. The first thing we need to do to get started is we're going to create a new program. We're going to do it using blocks, and we're going to select Sphero Mini. So for the first activity, or the first challenge that's listed in Schoology, it says, I want you to draw a perfect square that drives 1 foot by 1 foot. The side's going to be 1 foot by 1 foot. So before we start creating our looped function with our variables, the first thing that you need to do is we need to figure out how far, or I should say how fast and for how long we need to drive in order to do 1 foot. So every tile on the floor in the classroom is 1 foot. It's a 1 foot tile. So what we need to do first, I'm just going to type in some numbers because I'm not actually programming anything right now. But we're just going to pick a speed. I'm just going to say, I'm not saying this is the right speed. Let's even go a little lower. Let's do 47. You can type in, let's do 50. Okay? We'll do 50. I would recommend that you don't do super high speeds because we're going to be drawing these and immediately be turning. So the faster they go, the more inaccurate they're actually going to be. And let's just say that I drive 50 for 2 seconds. I don't know if that's true or not. So you have to figure out whatever speed you want to drive at, how long is 1 foot. So now that we've established this being 1 foot, we are now going to start creating our program to draw our first shape. In this case, it's going to be a square. You may have noticed at the bottom of your menus down here, there is a double-sided arrow. It looks like a less than and a greater than sign that if you click on it, it'll actually expand and you can see more options here. We're going to scroll over and we're going to grab the loop block, which is under the light purple called controls. We're going to drag that up and we're going to snap this inside. Now, since it's a square, squares have 4 sides, we are going to create a program that we are going to loop 4 times. We're going to create some code that's going to loop 4 times. Now, the issue with the code as it exists right now is that we are simply just driving forward. And then we're driving forward, and we're driving forward, and once again, we're driving forward. So we need to figure out how do we get it to turn 90 degrees in this case every time that we complete a side. We also want to, let's do this part right now while we're under the same menu here, the controls menu. I want to grab a delay block, and I want to put that underneath here. And I want to have it delay for 1 second before it loops back to the beginning. The reason we're going to have it delay is so that the Sphero has actually a time to stop before it's immediately turning and driving, just to keep it as accurate as possible. So we're going to go slow speed, 50% speed, I should say not 50%, 50 speed for 2 seconds, and then we're going to stop, and then we're going to draw the other side, and then we're going to stop and draw the other side. So the slower your robot goes and the more delay that you have to let it settle down before it turns, the more accurate it's going to be. Now here's where it gets a little bit tricky, so you have to follow along with me here. I'm going to do a few steps, and you're going to replicate these to do the other shapes too. And I'll tell you how to use this code as a template to do the rest of them. Across the bottom, we are going to select variables. Now we don't have a variable established or created yet. So we're going to click on Create Variable, and we're going to type in the word angle, A-N-G-L-E. We're going to say that's going to be a number, and I'm going to hit the green check here, or the blue check at the top right. And so now we see down on the bottom, we have 2 more blocks that we can use that were created. So to give you an idea of what a variable is, it's a number that can change as other things throughout the loop, maybe. In this case, that's what it's going to be. But just think of it as a number that can change or is impacted or affected by something else. I'm going to drag this set angle up to here, and I'm also going to drag this angle variable into the 0 degree. So what we're doing here right now, we're driving straight 4 times, but I want that to degree every single time that this repeats back to the beginning to change. So what it needs to do is we need to make it be 90 more degrees in this case, more than the previous number. So if we're driving at 0 degrees and we drive 1 foot, we're going to turn 90 degrees. And we're going to drive 1 foot, and then we're going to turn to go 180 degrees. And then we're going to drive a foot, and then we're turning and adding another 90, which is 270. So here's how we're going to create that. We are going to go to the, let's see it here, Operators tab, and I'm going to expand that out because I need this block right here. You might also notice that there's some different shapes here. So for instance, I have a rectangle here. Here's a hexagon. Only the same shape will fit inside certain blocks. That's intentional. Okay, so if I were to try to drag this thing in here, it's not going to fit because it's a hexagon. Okay, this one right here is what we're going to use. And we're going to grab that variable block again that says angle, and we're going to snap this into the first section. We're also under where it says 0, we're going to type 90 in this case since we're doing a square. So let me explain what's happening with this code. When we first start, the direction is going to by default be 0 degrees. And it's immediately, before it even starts driving, it's going to turn 90 degrees. And then what's going to happen is it's going to roll at 90 degrees at speed 50 for 2 seconds. Delay, stop, and as it rolls back to the beginning, our number, our angle, remember it's 90, we're going to add another 90 to it. So this angle value becomes the previous number plus 90. So this should drive us in a square, 1 foot by 1 foot square, considering that you have figured out the proper speed and time in order to drive 1 foot. Once we have this one completed, I'm looking on Schoology here, let's see, the second challenge listed says, I want you to drive in a perfect triangle with sides that are 2 feet by 2 feet. So what I'm going to have you do for today for the exit ticket, you need to complete all 4 challenges, and I want to see all 4 sets of code on one screen, and you're going to screenshot it to capture all 4. So I'm going to pinch my fingers together and I'm going to zoom out. I'm going to move this one over here. So this is code number 1. I'm going to show you a little bit of a hint also. And I'm going to be holding right next to where it says loop 4 times, I'm holding right around where it says times. If I hit duplicate, I can take this same structure and I can drag this over. So here's my square that I just created, right here. We're now going to create a triangle. So I'm going to get you started through this one, and then I want you to complete the other ones. Pentagon, which has 6 sides at 1.5 feet, and an octagon, which has 8 sides at 1 foot. So the thing that we need to note here when we're converting this code from a square to a triangle is how many times it needs to loop. So in this case, we're doing a triangle. It's going to be 3. And I'm jumping down to the green block now. If we know that 50 for 2 seconds drives a foot, in this case, we're going to use that to drive 2 feet. So the easiest way to do this, in my opinion, is not to change the speed, but we need to go twice as far. So let's just increase the amount of time that we're driving it. So now 4 seconds is 2 feet. Now you might have something that just is, let's say your driving 1 foot is 1.7 seconds. So 1.7 times 2 would be 3.4. So you just have to double whatever your seconds are for your square. There's one major change that we need to make here, and that is under the number 90. So how you determine how much we have to turn is going to be the number 360 degrees, divided by the number of sides, or the number of angles in this case that you're turning. So in this case, it's 3. So we need to turn our robot 120 degrees, 120, every single time that we're looping. So 120 should get you pretty close to your perfect triangle. That is 2 feet by 2 feet. So that's challenge number 2. Let's assume that that one works. Go ahead and try it in the meantime. Pause the video. So this is challenge 2. I can duplicate either of them. Duplicate. Drag this back. And we're going to do the same process for a pentagon. So that's 6 sides that are 1.5 feet. And then an octagon, 8 sides at 1 foot. Once you have all 4 of them done, I want to be able to see all 4 codes. So however you want to stack them in here, that's fine, but I want to see all 4 of them. Screenshot that. You can airdrop it to your partner, or if your partner doesn't want to accept airdrop, they can simply just take a picture of your screen. Make sure that we're taking turns going back and forth with the coding if you are working with a partner. I do not just want one person doing all of the coding. So that is how we use variables and loops to create shapes.